Hello everyone, my name is Amy. Today I'm glad to introduce the results of our group research. The first page shows our project team members' name. Please have a look. Our investment procedure consists of 5 steps. Firstly, we research ETF options online, and secondly, we analyze exposure to different factors. And thirdly, we analyze the costs involved in each ETF options. And fourthly, we select the ETFs by the cheapest way to get exposure to selected factors, and we construct the optimal portfolio. And lastly, we combine different factors with portfolio weights. We have recommended this ETF portfolio to our investors. So the factors we chose were market size and value. We chose these factors because we believe these factors will give the most exposure in their respective ETFs while minimizing the cost to implement these factors. After getting the organized dataset, we performed multiple linear regression to evaluate their performance in terms of their exposure to the factor. The regression allows us to obtain the beta, alpha, and also the tracking error for each ETF relative to the factor itself. We firstly use the factor return as X and ETF return as Y, and the general formula for the regression is shown on the slide. So this step is to test the fitness of the factor model on the ETFs, and we pick up 5 ETFs with higher R-square in the following calculations. So the specific results could be found on our notebook. Then we use factor return as Y and ETF return as X. So the table below is our regression summaries for each factors. So taking the factor size as an example, the negative constant means that it has an inactive alpha, while the alpha is not significant with 95% confidence interval. So all ETFs have significant exposure to the set factors. So since the corresponding betas have p-values smaller than 0.05. So moving to our next step, we are going to rank these ETFs based on their cost. So that is tracking error over the beta. So in other words, those ETFs with lower tracking error are cheaper in terms of the unit exposure to the factor based on their tracking error ranking. Then we try to build a tendency portfolio by tracking the market portfolio. We evaluate the tendency portfolio under both the minimum variance and risk parity assumptions, and we also obtain the higher Sharpe ratios, meaning that the portfolio is effective and also the risk-based diversifications. The betas on the graphs are all significant according to their t-value, and also those showcase the portfolio exposure to equity risk factors. And we have the conclusion that in the time period of our analysis, the ETFs that we pick don't perform similarly as their corresponding factors, as they have different returns and volatility from their pure factor peers. Besides that, generally speaking, we also recommend the ETF portfolio since ETF can be freely traded like stocks, and also ETF stable exposure to different factors. And it provides good diversifications because it is designed to track the indexes containing the hundreds of stocks and help investors to avoid company-specific risks. And lastly, we still have some limitations on research, such as the limited time frame, and we also have limited access to ETF's universe selections. So that's all for our presentation. Thanks for watching.